everyone, today we will be talking about geology and earth science.
First of all, I will introduce a little bit about our topic, which is geology and earth science and its significance. Geology. The word geology means study of the earth. Geology is the primary earth science and looks at how the earth forms, its structure and composition, and the types of processes acting on it. By studying the structures of the earth, we can unlock its hidden past and anticipate its future. Earth science. For earth science is the study of the earth structure, properties, processes, and 4.5 million years of biotic evolution. Understanding this phenomena is essential to maintenance of life on the planet. This expanding world population demands more resource, face increasing losses from natural hazards, and release more pollutants to the air, water, and land. Next, the significance of geology and earth science lies their crucial roles in understanding our planet and addressing various particle and essential challenges. For geology, we have two significance, which is resource management and environmental protection. For resource management, geology helps in locating and managing natural resources such as minerals, oil, gas, and groundwater. Understanding geological formation and processes is essential for efficient and sustainable extraction. For environmental protection, geologists assess soil and water contamination and help develop strategies for pollution control, waste management, and environmental restoration. For earth science also have two significance, which is climate change understanding and space exploration. For the climate change understanding, earth scientists study climate system and change over time, helping to understand global warming, its causes, and its potential impacts on the environment and human societies. For space exploration, astronomy, part of earth science, enhance our understanding of Earth's place in the universe, contributing to space exploration and the study of other planets.
Next, I will talk about an explanation of geology and earth science relevant to the scientific instrumentation and application concept. For the scientific instrumentation in geology and earth science, the first one there is seismometers. It used to detect and record earthquakes by measuring ground motions. They help in understanding seismic activity and the internal structure of the earth. The second one is magnetometers. It measures the earth's magnetic field to study the earth's core and identify mineral deposits. The next one we have spectrometers. It used in geochemistry to analyze the chemical composition of rocks, minerals, and fluids. Other than that, we also have electron microprobes. It measures the chemical composition of small volumes of minerals and rocks with high precisions. Last but not least, there is also remote sensing instruments. It includes satellites and drones equipped with sensors, for an example, light detection and ranging, multispectral and hyperspectral cameras to map and analyze surface features and compositions. Let's move on to the application of scientific concept and instruments. The first one, there is earthquake monitoring and prediction. In earthquake monitoring and prediction, there is seismology. Analyzing seismic waves helps in understanding earthquake mechanics and predicting future seismic events. There is also early warning systems. Seismometers link to the network that can provide early warnings to reduce the impact of the earthquakes. The second one is environmental and climate studies. In environmental and climate studies, there is hydrology. Instruments measuring water quality and flow rates help manage water resources and study hydrological cycles. There is climate monitoring. Meteorological instruments measure atmospheric parameters, contributing to climate models and weather forecasting. The last one is geological mapping. Remote Sensing and Geographic Information System (GIS). It provides detailed maps of geological features, helping in land use planning and hazard assessment. There is also field mapping tools. GPS and mobile GIS applications enable precise location tracking and data recording during fieldwork.
First is seismology and earthquake studies. The technology that have been used in seismology and earthquake studies is seismometers. Function of seismometers are to detect and record ground motions caused by seismic wave from earthquake, volcanic activity and other sources. There are two applications of seismometers. First one is earthquake monitoring. Networks of seismometers provide real-time data on earthquake, helping to locate epicenters and determine magnitudes. Second one is early warning systems. Seismometers networks can trigger alarms before damaging seismic wave reach populated areas, providing crucial seconds to minutes for people to take cover. Second is remote sensing and satellite imagery. The technology that has been used is remote sensing satellites such as LiDAR, multispectral and hyperspectral imaging. Function of LiDAR is uses laser pulse to create high-resolution 3D maps of the Earth's surface, penetrating forest canopies and providing detailed topography. And the function of multispectral and hyperspectral imaging is to capture image in multiple wavelengths to identify different materials based on their spectral signatures. There are two applications of remote sensing and satellite imagery. For example, geological mapping and environment monitoring. For geological mapping, they identify rock types, structures, and alterations from space, aiding in geological mapping and mineral exploration. For environmental monitoring, they track changes in land use, deforestation, soil erosion, and water bodies, contributing to environmental protection and management.
And now, I will talk about example of geology and earth science real-world implementation. The first one is Shake Alert. It is for earthquake early warning system and it is located at California, USA. This implementation uses a technology network of seismometers that connected to a centralized processing system. This technology will detect the initial, which is less damaging P waves of an earthquake, and it will quickly calculate the intensity and arrival time of the more destructive S waves. Alert will be sent out to the people and automated system. The impact of this implementation can provide seconds to minutes of warning, which allow people to take cover, to allow system to shut down such as gas lines and trains, and also for emergency service to be prepared. The second one is Flint Water Crisis Response, and it is used for pollution and environmental health. This implementation is located at USA. This technology contains a water quality sensor, geochemical analysis, and geographic information system, GIS. Water quality sensor and geochemical analysis will detect contaminants in the water supply, and GIS maps the distribution of contaminated areas and identifies sources. This technology helps to identify the extent and source of lead contamination in Flint's water supply, and also guided public health responses and infrastructure improvements to restore safe drinking water. Now, I will talk about potential benefits and challenge. For potential benefits, the first one is resource management and exploration, which is used to identify and extract oil, natural gas, coal, and geothermal energy resources. The second one is natural disaster mitigation. It will develop early warning systems and seismic hazard maps to reduce the impact of earthquakes. The third one is environmental protection and conservation pollution monitoring, which is to identify and mitigate soil, water and air pollution through environmental monitoring and remediation strategies. The challenge is technical and methodological challenge, data limitation, which is difficult to obtain high quality and high resolution data from remote or inaccessible areas. Environmental and social impacts, resource extraction, which will cause the environmental degradation, habitat destruction, and pollution that contributed from mining and drilling activities. Regulatory and policy issues, regulation compliance, navigating complex regulations and ensuring compliance with environmental and safety standards.
Next, future development and innovation. First, advanced remote sensing and imaging technologies. Future developments, hyperspectral imaging is to enhance capabilities to capture a wider range of wavelength, allowing for more precise identification of minerals and environmental conditions. Next, advanced LIDAR, improved resolution and accuracy of topographic mapping and vegetation analysis even under dense canopies. For innovation, CubeSats and small satellites. Deployment of constellation of small, cost-effective satellites providing high temporal and spatial resolution data. Other than that, AI and machine learning. Integrating AI to process and analyze vast amounts of remote sensing data, improving accuracy and efficiency in detecting geological features and change. Now, let's move to big data and artificial intelligence. For future developments, data integration, combining data from diverse sources into comprehensive database. For predictive analytics, using AI and machine learning to predict geological events such as earthquakes, volcanic eruptions, and landslides. For innovation, real-time monitoring and analysis, implementing real-time data processing system to provide immediate insight and alerts for nature disaster response. Other than that, enhanced modeling, developing more accurate and dynamic geological models that can simulate complex interaction within Earth system. To summarize, we have deepened our knowledge about geology and earth science. Our purpose was to shed light on this fundamental aspect of geology and earth science, emphasizing their profound impact on our environment and our life. As the renowned geologist James Hutton once said, the present is the key to the past. By understanding the geological history of our Earth, we gain invaluable insight that help us prepare for and mitigate future challenges. I encourage each of you to delve deeper into this interesting field, to appreciate the complexity of our planet, and to consider how geological processes affect everything from our nature, resource to our safety. Thank you all for your time and attention today. It has been a privilege to share this knowledge with you.
The same cloud hanging over my head. God, I wish you were